Now, this control system are of two types, that is open loop system and closed loop control system. And there is only difference between the open loop and closed loop control system is that closed loop control system has the feedback which is not present in the open loop system. Now come to open loop system. Now in the open loop system we will have the reference input, which is also known as the reference, and then input transducer. Transducer actually converts the form of the input. Let us suppose that we want the controller to see the signals as the electrical signals and work on that. So this transducer, input transducer, converts the signals into any type of signal into the electrical signal. So it acts as a transducer. Then we will have the controller, and the main function of the controller is to drive the plant. So it will do that, and after that we will have the processor, the plant, which actually works. And the input the input are the reference, and the output in that case is the controlled variable. Also we will have some disturbances in that which are added to the system as the summing points. Now a simple example you will see, a plant can be a furnace or the air conditioning system, where the output variable is actually the temperature, and the controller is the heating system, which consists of the fuel valves and the electrical system that operates the valve. So it is a simple example of this open loop control system. Now one disadvantage of this open loop control system is that it cannot compensate for the disturbances. That is, it means that let us suppose that if a controller is an electronic amplifier, and in this case let us suppose that disturbance 1 is noise, then any additive amplifier noise at the first summing junction will also drive the process, corrupting the output with the effect of the noise. So the output of the system is corrupted not only by the signals that add to the controller commands, but also by the disturbances at the output. So that is not required in actual control system what we want. The simplest example of this closed loop control system is the toaster that we are using in daily life. In case of toaster, the controlled variable, that is output, is the color of the toast, and the device is designed in such a way with the assumption that the toast will be darker longer it is subjected to heat. So there is no check on the color of the toast. We are assuming that this would be the scenario, and it will work accordingly. So another important disadvantage of the open loop system is that it is the sensitivity to disturbances and inability to control these disturbances. So that is why we are using the closed loop control system. That is, in case of the closed loop control system, we will have one output transducer or the sensor which is connected with the controlled variable, and it will sense the output and compare it with the desired output, and as a result an error signal is generated. Now in case of the closed loop control system, the output transducer or the sensor, it measures the output response and converts it into the form which is required, that is required by the controller. Now let us consider an example. Suppose that controller uses the electrical signals to operate the valves of temperature control system, and the input position and output temperature are converted into the electrical signals. That's the obvious. Now the input position can be converted into voltage by using a simple device which is known as potentiometer, which is actually a variable resistor, and this output temperature can be converted to voltage by using a thermistor. So what is a thermistor? So thermistor is a device whose electrical resistance changes with temperature. So in this way we are getting internally the electrical signals. Now When we are getting the feedback, we will have the summing point at initially we will have the summing point after the input transducer. Now this summing point, the difference between this input reference and this obtained, that is the signal obtained from the output or the control variable, we are getting the actuating signal. That is, if there is the difference between the two, then the actuating signal is generated. However, in the system where both the input and the output transducers have unity gain, then the actuating signal value is equal to the difference between the input and output signals, and under this condition this actuating signal is known as the error. Now from this you can see the closed loop system compensates for disturbances by measuring the output response and feeding that measurement to the through the feedback path, compare it with the input, that is a reference, and if there is any difference between these two responses, then it drives the plant through the actuating signal to make the correction. So self correction system is there in case of closed loop system, and if there is no difference, then it doesn't drive the plant. So it is very important from industry point of view. Now let us see the difference between the closed loop system and the open loop system. What is closed loop and open loop system? So from this it is obvious that from the previous discussion it is obvious that the closed loop system is more accurate as compared to the open loop system. Also the closed loop system is less sensitive to noise disturbances and changes in the environment, because it has the self correction property. Also we can see that transient response and steady state error can be controlled more conveniently and with greater flexibility in case of closed loop system as compared to open loop system. That is for that sometimes that is by the simple adjustment of gain, that is amplification in loop, and sometimes by redesigning the controller we can control the transient response and the steady state error. So redesigning means that we have to use some compensating device, or we can use some hardware which is known as the compensator. On the other hand, this open loop control system, it cannot be easily controlled. One important point is that the closed loop system are more complex and expensive than the open loop system. So it is more complex and expensive, so money is also an issue, so we have to take into consideration that also while designing any system. Now let us take an example of the toaster. In case of a closed loop toaster, you will see that since it has the feedback path, so it will measure both color and through the light reflectivity and humidity in the feedback path. So then it will do the comparison at the summing point. So in this case it is costly. And open loop toaster, the control variable is the color of the toast, and we have assumed that toast will be darker, larger, it will be subjected to heat. So the control engineer, so it's the job of the control engineer that there must be the trade-off between the simplicity and the low cost in case of open loop system, and accuracy and higher cost in case of closed loop system. So that is also taken into consideration by designing any system.